Ayun. So, tuloy natin yung ating pag-aaral sa work. Ayan. Dito na tayo kanina. Okay. So, balik lang natin ng konti at himayin natin ito ng gusto. So, sabi rito ay welcome. Tuloy-tuloy nyo lang panoorin yung video. Continuation lang ito nung previous video. So, na-establish na natin yung simplistic lang yung kanyang definition dito or derivation ng formula. It's just a simple derivation. So, doon sa figure 3-4, figure 3-4, yan yung PV curve. Okay, kung naalala nyo yung Boy's Law, ito yun, yung curve na yan. Diba? Yung P, kapag maliit yung P mo, diba? Ito yung P. P1, ito yung P2. Sorry, ito yung P1. Ito yung P2. Pansin nyo, sa P1, maliit yung volume. Ito ay 0. V ito. Pressure yun. So, sa P1, mataas yung pressure. Nag-expand. Bumaba ang pressure. Lumaki naman yung volume. Di ba? Sa P1, ito yung V1 niya. Maliit. Ayan. Kung 0 yan dito, di maliit lang. Pero mataas yung pressure. Kung mapapansin itong curve na to, ito yung susukatin mo to get the work. Kasi yung travel niya ito. From B2 na ito. B1 to B2, ito yung kanyang sweep. Ito yung kanyang distance. Okay? So, yan ay galing sa Boy's Law. Nandiyan pa yung Boy's Law, no? Hindi lang natin napapansin. Pero Boy's Law is still alive. So, sabi ni Boy's Law, pressure is equal to sum of constant times 1/V. Ito yun. Application ng Boy's Law. Siya nangyari to doon nga sa cylinder. Pag nag-expand yung cylinder, taas yung pressure niya sa P1. Pero maliit yung volume. Ayan, maliit yung volume. Diba? Maliit ang volume sa P1. Pero mataas yung pressure. Ayan yung volume. Okay? So much for that. So ngayon, we are interested for the work. Work. Work is what? Work is under the PV diagram. At yun na nga, kung balikan natin, sabi niya, yung work 1 to 2 is equal to the integral of V1 to V2. Okay? So, yan. So, yung work mo dito, since we are interested, work mo daw dyan, work 1 to 2. Itong work mo na to, 1 hanggang 2 is equal to the integral of your V1 to your V2, provided that pressure is equal to P dV. Ito yun. Okay, yun yung general expression ng work in this scenario. Okay? So, sabi niya, however, the work done, written simply by W, we would never write W1 or W2, since work is not associated with the state but with the process. Process in the state. Ano? Work is not property. The integral of the exact differential, for example, dt, would be, ito yan. So, parang delta T lang, where T1 is the temperature at state 1 and T2 is the temperature at state 2. Okay? Okay. So, yan. So, sabi niya, the second observation to be made in 3.4, doon sa 3.4, babalikan natin yung 3.4 na sinasabi niya. So that we'll be able to understand what he's saying ito. Yeah, 3.4. Okay? So, going back here, ang sabi niya, that PV diagram in 3.4, equilibrium state can usually be assumed even throughout the variables may appear to the changing quite rapidly. Sabi niya, combustion is very rapid process that cannot be modeled as quasi-equilibrium or quasi-equilibrium process. The other processes in the internal combustion engines, expansion, exhaust intake, and compression, can be assumed to be quasi-equilibrium process. They occur at low rate thermodynamically. Okay, yun yung ano niya, yung sinasabi niya, yung application ng quasi-equilibrium is for the processes of internal combustion engine such as expansion, exhaust intake, and compression. Bakit? Kasi nga rate ang kanilang rate is low. So, as the final comment, so malaga to kasi final comment ito. Regarding the work, we may now discuss what is meant by a simple system as defined in chapter 1. Dun sa chapter 1. For the system free of surface, magnetic, electrical effects, the only work mode is damp, the pressure acting on the moving boundary. For such simple system, only two independent variables are necessary to establish an equilibrium state of the system composed of the homogeneous substance. If other work modes are present, such as work mode due to the electrical field, additional interdependence variables would necessary, such as electrical field intensity. So in this case, hindi natin kailangan yun kasi nga we are we are under the assumption na ito ay walang magnetic, free surface ito, walang magnetic, at walang electrical effects. Okay? So, yun yung kanyang sinasabi. Let's jump into the example. So, may example tayo para ma-reinforce tong theory na ito. No? So, sabi rito, 1 kilogram of steam with a quality of 20% is heated at a constant pressure of 200 kilopascal until it reaches 400 degrees Celsius. Calculate the work done by the steam. So, paano may calculate? So, ito na yun. Integral kagad ang gagamitin mo na rito. No? Kaya, reviewin nyo yung integral nyo. Class. Okay, so, dito, yung given is ito. Plug in mo na kagad kasi alam naman natin itong formula na ganito. Work is equal to the integral of P dV. Okay? Solve it. Ito na yung mangyayari dyan. Yan. Yan na pinakita, no? Na kung paano naging process dyan, yung W. Ilabas pa niya yan eh. Ilabas mo yan ditong P. Integral ng V1 to V2. Tapos, dV. Di ba? Tapos, substitute mo yung dito. That is equal to V2 minus V1. Wala na integral times yan. P. Quantity yan. So, shortcut nito kasi alam nyo na yan. Dahil tinuruan kayo ng integral and differential. So, express P express V in terms of mass times specific volume. Then you have specific volume here and you have mass and pressure here. So from steam table, you will get, di ba, yung V is equal to Vf plus X tapos Vg minus Vf. Since given yan, di ba, may given na 20%, that's your X, 0.2. Ano pang given? Vg, Vf, and Vg. Plug in the formula, then you will have a specific volume. Okay? After that, find the superheat At after that, from the superheat table, we locate state 2. Kasi hinahanap yung state 2 eh. That is 400. The temperature niya is equal to 400 degrees Celsius. You will have a corresponding pressure, which is what 0.2 megapascal given yan, 200 kPa. So you will have V2. So the work is what? The work is equal to, alam mo na eh. So may formula ka. May mass ka, di ba? 1 kilogram. Tapos may pressure ka na 200 kilopascal. Meron kang alin? V2, which is 1.549. V2 minus what? V1, which is yung V1 mo. Ito yun. 7.1780. So, plug in. Okay. To that formula. And then, perform numerical calculations. You will have 274.2 kilojoule. Note, with the pressure having units of kPa, the result is in kilojoule. So mag-ingat tayo sa mga mga natin unit. Okay? Thank you.